predator becomes prey in the Florida Everglades as hundreds of hunters descend on the Sunshine State to catch and kill as many Burmese pythons as possible.
Predators are becoming prey in the Florida Everglades. Across the vast wetlands of South Florida, hundreds of hunters are descending into the marsh with one mission: find and remove as many Burmese pythons as they can. To most people, the Everglades is simply a sprawling swamp filled with alligators, sawgrass, and dark winding waterways. But beneath that familiar image, another story has been unfolding for decades. There is a war happening in the tall grass, and the enemy is almost impossible to see. An invasive predator has established itself across one of America's most important ecosystems, consuming animals that once seemed too numerous to disappear. For years, scientists and wildlife managers believed they understood the scale of the invasion. They believed they had a rough idea of how many snakes were out there. But then something happened that forced them to look at the landscape in a completely different way. It took fire to reveal what the grass had been hiding. The air in the Everglades is heavy with heat and humidity, the kind that clings to your skin and makes every breath feel warmer than it should. But on a morning in December 2025, the heat is coming from somewhere else. Along the edge of a sawgrass prairie, a crew from the Florida Forest Service moves carefully across the landscape, carrying drip torches. These metal containers release a controlled stream of fuel, and the workers are not there to extinguish a fire. They are there to create one. Within minutes, a thin line of flame begins crawling across the vegetation. Orange fire consumes the dry grass, crackling so loudly that it overwhelms the insects and birds around it. Smoke rises into the Florida sky, transforming the blue horizon into a wall of gray. To anyone watching from a distance, it looks like destruction. But in the Everglades, fire can also be medicine. For thousands of years, fire has been part of the natural rhythm of this landscape. Lightning strikes would ignite dry vegetation, clearing away old growth, recycling nutrients, and preventing trees from overtaking the open grasslands. The Everglades was not simply capable of surviving fire. In many places, it evolved with it. But today, prescribed fire has taken on another purpose. It has become one of the tools used in a desperate struggle against an invasive predator that depends on vegetation for concealment. As the wall of flame moves forward, the marsh begins to react. Grasshoppers leap from the grass. Birds swoop down after fleeing insects. Marsh rabbits race toward whatever cover they can find. And then something much larger begins moving through the vegetation. The grass bends and parts under a slow, powerful body. A Burmese python, perhaps 10 feet long, is suddenly forced from its hiding place. For the snake, the problem is not the fire alone. It is exposure. A Burmese python's patterned skin is remarkably effective camouflage in the Everglades, where shadows, roots, mud, and reflected sunlight can break up the outline of a massive animal. But against blackened earth and bright flames, that camouflage becomes almost useless. The snake stands out. It has nowhere to disappear. During a prescribed burn in Palm Beach County in April 2025, land managers witnessed this effect firsthand. As the fire stripped away the tall vegetation, snakes became visible across areas that had previously seemed almost empty. What had been hidden beneath the sawgrass suddenly appeared in the open, creating a disturbing realization. The infestation was not simply concentrated in a few isolated pockets. The snakes were occupying a landscape far larger than anyone could easily search by conventional methods. That is the fundamental problem of hunting Burmese pythons. The Everglades is enormous, and the vegetation can be so dense that a large animal can disappear only a few feet away. A snake does not have to run from a hunter. It simply has to remain still. In the middle of dense sawgrass, a python can become almost indistinguishable from the landscape around it. But fire changes the equation. When the vegetation disappears, the snake is forced to move. Reports from the field describe pythons emerging from the smoke and attempting to reach canals, deeper water, or patches of vegetation that escaped the flames. In some cases, females have been discovered near nests containing eggs. What had been an invisible threat suddenly becomes a target that hunters can actually see. Fire does not eliminate the snakes by itself. Instead, it changes the battlefield, turning the python's greatest advantage, its ability to vanish, into a temporary weakness. But the most disturbing revelation comes after the flames pass. When the grass is gone, the landscape can look strangely empty. The raccoons that once moved through the marsh are difficult to find. Opossums are scarce. Foxes and bobcats have declined in areas heavily affected by the invasion, and the enormous flocks of birds that once gathered around shallow pools can appear diminished. Tree islands that once supported wildlife now seem quiet and overgrown. The fire reveals the pythons, but it also reveals something more disturbing: absence. You can see it in the empty mud, the missing tracks, the abandoned burrows, and the lack of movement in places that should be alive with activity. The burn becomes more than a hunting technique. It becomes a window into the ecological damage caused by an invasion that spent decades operating almost completely out of sight. To understand how the Everglades reached this point, you have to go back several decades. The story begins not with a government program or a scientific experiment, but with the exotic pet trade. During the 1980s and 1990s, South Florida became a major center for exotic animals. Burmese pythons were among the species people wanted to own. As babies, they could be small, manageable, and even attractive. A 20-inch snake could curl around someone's arm without seeming particularly threatening. But Burmese pythons do not remain 20 inches long. They grow rapidly, becoming 6 feet, then 8 feet, then 10 feet or more. Eventually, the animal that once looked like an unusual pet becomes a powerful predator requiring enormous amounts of food and specialized care. That is where the problem began to expand. Some unwanted snakes were released into the wild, while others escaped from captivity. What may have seemed like an isolated act at the time became something much more consequential when those animals encountered the Everglades. The environment offered almost everything a large constrictor could want: warmth, water, dense vegetation, abundant prey, and relatively few predators capable of threatening an adult python. Each escaped or released snake was effectively entering an ecosystem that was already perfectly suited to its survival. One snake became another. Another became a breeding population, and slowly, almost invisibly, the foundation for an ecological invasion was established. Then came Hurricane Andrew in 1992. The storm devastated South Florida, destroying homes and infrastructure while also damaging facilities that housed exotic animals. Escapes occurred, and the storm became an important part of the history of the python invasion. The Everglades provided an ideal refuge for animals that suddenly found themselves outside captivity. It was warm, wet, and filled with potential prey. There were rabbits, raccoons, opossums, birds, rodents, and other animals moving through the marsh. For a predator capable of swallowing surprisingly large prey, it was almost an unlimited food supply. The presence of alligators did not eliminate the threat. The Everglades already contained one of the most formidable predators in North America, but Burmese pythons introduced an entirely different hunting strategy. There have been documented encounters between pythons and alligators, including cases in which a python attempted to consume an alligator and died in the process. These confrontations look like clashes between giants, but the real danger is not one dramatic battle. It is the python's ability to move through the landscape and exploit prey in places where native predators cannot easily respond. An alligator may defend a territory or a pond. A python can move from one territory to another, searching through vegetation and waterways, consuming prey and continuing onward. The alligator guards a resource. The python can systematically empty it. For years, the invasion remained largely invisible. That is what made it so dangerous. Burmese pythons are ambush predators. They do not need to chase prey across open ground. They wait. They hide among roots, mud, vegetation, and shallow water. Their ability to remain still makes them extremely difficult to detect, even when they are living surprisingly close to people. By the time scientists and wildlife managers fully understood how widespread the population had become, the snakes were already deeply established. What looked like a handful of escaped pets had developed into a large, reproducing population capable of reshaping the ecosystem. The ecological consequences have been severe. Studies of areas invaded by Burmese pythons have documented dramatic declines in several native mammal populations. Marsh rabbits, raccoons, and opossums have suffered enormous losses in heavily invaded regions, while other species have also been affected. The result is not simply fewer animals. It is a disruption of the entire food web. When a superpredator removes large numbers of prey animals, native predators lose their food source as well. The effects can move upward through the ecosystem like falling dominoes. Animals that never encounter a python directly can still suffer because the snake has consumed the prey they depend upon. And then there is reproduction. Burmese pythons are capable of producing large clutches of eggs, allowing populations to grow rapidly when conditions are favorable. A single female can produce dozens of offspring, and even if only a portion survive, the result can be a substantial increase in the number of predators entering the ecosystem. This is why the problem cannot be solved simply by removing a few large snakes. Every breeding female represents the possibility of another generation spreading through the marsh. The exact number of Burmese pythons living in South Florida remains difficult to determine. Estimates have varied widely, with some models suggesting populations numbering in the tens of thousands and potentially much higher. The uncertainty itself is part of the problem. Nobody can simply walk through the Everglades and count them. For every snake visible on a road, beside a canal, or in a recently burned area, countless others may remain hidden in vegetation, wetlands, and mangrove habitat. The snakes have demonstrated an extraordinary ability to survive, move, and exploit new environments. They have expanded beyond the deepest parts of the marsh, entered mangrove systems, and demonstrated that water is not necessarily a barrier to their movement. This is why prescribed burns have become such an important part of the strategy. The problem is not simply that there are too many pythons. The problem is that the vast majority of them cannot be seen. You cannot effectively remove an enemy that remains invisible. For roughly 3 decades, the snakes have had time to establish themselves, reproduce, and spread across a landscape that is extremely difficult for humans to search. Now, wildlife managers are trying to catch up. They cannot burn the entire Everglades, and they cannot remove every python one by one. Instead, they are attempting to change the conditions of the hunt. Fire temporarily strips away the python's greatest defense. It opens the vegetation, exposes the ground, and forces hidden snakes to move. It gives hunters a brief window when a landscape that normally conceals everything becomes unusually visible. The strategy is not a simple solution, and it is not a guarantee of eradication. But it gives researchers and hunters something they desperately need: an opportunity to see the enemy. And that is what makes the sight of smoke rising over the Everglades so different from an ordinary wildfire. The flames are not simply consuming vegetation, they are revealing a hidden battlefield. Beneath the smoke is a decades-old ecological struggle, one created in part by human actions and now requiring an enormous human effort to control. The question is no longer whether Burmese pythons have changed the Everglades. The evidence suggests that they have. The real question is whether humans can change the course of that invasion before the landscape itself is permanently transformed. The Everglades has survived hurricanes, droughts, fires, and enormous environmental changes. The sawgrass will grow again after the flames disappear. But when the green returns, the pythons will still be waiting beneath it. And that leaves wildlife managers facing an uncomfortable reality. The war is not won when the fire goes out. The fire only opens a temporary window. The real battle begins when the smoke clears. The hunters move in, and they try to find what has been hiding in the grass all along. And all the while, the enemy is watching. Not in the way we imagine a predator watching its prey, but in a far more unsettling sense. Every time humans enter the marsh, every time engines cut through the waterways, every time a fire strips away the cover, the pythons are being exposed to a new set of pressures. The snakes that remain are the ones that survive those encounters. They retreat deeper into vegetation, disappear into canals, change when they move, and become harder to detect. The question is no longer simply how many pythons are in the Everglades. The question is whether the population itself is beginning to change because of everything we are doing to stop it. That possibility leads scientists into one of the most complicated questions in invasive species management. Can a predator actually learn to live with the methods being used against it? Evolution does not happen because an animal makes a conscious decision to adapt. It happens because some individuals survive while others do not, and the survivors pass their traits to the next generation. If the snakes that remain hidden are more likely to survive than the snakes that expose themselves, then over many generations, those traits could become more common. What began as a simple hunting strategy could become a pressure that reshapes the population. But there is an important distinction between what is theoretically possible and what has actually been demonstrated. A darker snake appearing on burned ground would not automatically prove that fire had created a new generation of black pythons. A snake becoming more cautious would not necessarily mean it had genetically evolved. Behavior can change without genetics changing at all. Animals can learn. They can become familiar with roads, vehicles, boats, noise, and human activity. And that may be exactly what makes this battle so difficult. We are not fighting a machine with predictable behavior. We are dealing with living animals capable of responding to an environment that is constantly changing. The same uncertainty surrounds the idea of an ash-dark python. Melanism exists in many reptiles, and genetic variation is a normal part of any population. But turning that variation into a widespread adaptation would require strong and sustained selection over generations. So far, the idea of pythons evolving specifically to disappear against burned ground remains a frightening hypothesis rather than an established fact. Yet the thought is powerful because it captures the central problem of the Everglades. Every solution creates a new set of variables, and the fire is only one of those variables. The snakes are expanding beyond the places where the invasion first became notorious. Canals cut across South Florida like artificial rivers, connecting wetlands, agricultural land, roads, and developed communities. These waterways were built for people, but wildlife does not care what a canal was designed for. To a python, a canal can simply be another corridor through the landscape. Water provides shelter, prey, and a way to move without crossing exposed ground. That creates a disturbing possibility. The same infrastructure humans built to control water may also help an invasive predator move through the region. A snake does not need to understand a city. It only needs to follow cover, food, and favorable temperatures. A drainage canal can lead toward a neighborhood. a patch of vegetation can provide shelter beside a road. Warm structures, equipment, and shaded spaces can offer new places to hide. The boundary between wilderness and suburbia is not as solid as it looks on a map, and that is when the python problem becomes more than a conservation story. Imagine waking up in a South Florida neighborhood and finding a massive constrictor beside a pool. Imagine discovering one beneath a porch, inside a garage, or moving through vegetation behind a house. For people living near the Everglades, the idea may sound frighteningly close to reality. The deeper concern is not that every neighborhood will suddenly be invaded, but that continued expansion could bring more frequent encounters between an enormous invasive predator and the human communities surrounding its habitat. That is why fire cannot be the final answer. Fire can expose snakes. It can restore habitat. It can remove accumulated vegetation and temporarily make the landscape easier to search. But it cannot erase decades of population growth. It cannot burn every mangrove, every canal bank, every patch of private land, and every hidden refuge. And even if it could, doing so would destroy the very ecosystem humans are trying to protect. Then another problem enters the equation: climate. The Everglades is already a landscape defined by extremes. Water levels rise and fall. Wet seasons transform the marsh into a vast network of shallow waterways, while dry periods expose enormous stretches of grassland. Climate change adds another layer of uncertainty to that natural rhythm. Changes in rainfall, temperature, storm patterns, and drought conditions can alter the vegetation itself, changing how easily fire spreads and where animals can find shelter. A wetter period can produce taller, denser vegetation, giving pythons more cover. A prolonged dry period can leave the same vegetation dangerously flammable. That means prescribed burning becomes a delicate balancing act. Managers have to ask not only whether the landscape is ready to burn, but what will happen if the weather changes halfway through the operation. The most dangerous scenario is when fire moves beyond the vegetation and begins consuming the peat beneath it. The Everglades is not built entirely on ordinary mineral soil. Much of its landscape contains layers of accumulated organic material formed from generations of plants. When those layers ignite under severe conditions, fire can move underground, burning slowly through the organic substrate. That kind of fire is far more difficult to control and can cause damage that a surface burn never would. So the people managing these landscapes are walking a razor's edge. Burn too little, and dense vegetation provides refuge for the pythons. Burn too aggressively, and the fire itself can become a threat to the ecosystem. Burn at the wrong time, and the operation may accomplish almost nothing. Burn under the wrong weather conditions, and a prescribed fire can become an emergency. And somewhere beyond the burned line, the pythons remain. This is where the story becomes bigger than hunters, snakes, and fire. It becomes a battle between human control and ecological complexity. We introduced a predator into an environment where it did not belong, and now we are trying to remove it without destroying the environment that made the invasion possible in the first place. That is an almost impossible balancing act. But science is not standing still. If fire is the hammer, researchers are trying to build something much more precise. They are studying genetics, behavior, chemical signals, environmental DNA, thermal imaging, drones, detection dogs, and other technologies that might eventually make it possible to find pythons without burning enormous areas of habitat. One of the most futuristic ideas involves gene drives. In theory, genetic technologies could be designed to spread particular traits through a population far more efficiently than ordinary inheritance would allow. Researchers have discussed whether such approaches could someday be used to control invasive species by altering reproduction. The concept sounds almost like science fiction, change the genetics of a small number of animals, release them, and allow the altered trait to spread through the population over generations. But the more powerful the technology becomes, the greater the responsibility becomes. The Everglades is not a laboratory with walls. It is a living ecosystem containing thousands of species interacting with one another. Any genetic intervention would have to be studied with extraordinary caution. A mistake would not simply be deleted from a computer screen. Once a biological change entered the wild, reversing it could be extraordinarily difficult, or perhaps impossible. That is why the future of python control may not depend on one spectacular solution. It may depend on combining dozens of smaller ones. Fire could expose the snakes. Drones could search the open ground. Dogs could detect their scent. Environmental DNA could reveal where they have been. Radiotelemetry could show how they move. Hunters could remove the animals that are found. Scientists could then study what happens next. Each tool reveals another piece of the puzzle. And perhaps that is the most important shift of all. The goal is not simply to kill as many snakes as possible. The goal is to understand the invasion well enough to interrupt it. Because the Everglades is not just a swamp. It is a living system that has been evolving for thousands of years. Every canal, every fire, every invasive species, every storm, and every human intervention changes the conditions within it. The pythons are only one part of that enormous equation. When the flames finally disappear, the marsh does not become empty. It begins rebuilding itself almost immediately. Green shoots emerge from blackened ground. Insects return. Birds investigate the fresh vegetation. Small mammals begin moving through the recovering landscape. Water collects again in shallow depressions. The Everglades starts to heal. And somewhere beneath that new growth, a python may be waiting. That is the image that should stay with us, not the flames, not the hunters, not even the giant snakes pulled from the mud. The waiting. Because the fire only gives us a moment when the hidden becomes visible. Once the grass returns, the old game begins again. The predator disappears into the landscape, the hunters begin searching, and the ecosystem continues its struggle. The question is whether we can keep the balance long enough for native wildlife to recover. For decades, the pythons have had the advantage of darkness, distance, vegetation, and time. Now humans are trying to take those advantages away. One burn, one hunt, one detection, and one snake at a time. But the Everglades is enormous. There are places where boats cannot reach. There are mangroves too dense to walk through. There are canals disappearing into remote wetlands and stretches of sawgrass where a person can stand only a few feet from a giant snake without ever knowing it is there. For every python that appears on the blackened ground, another may remain hidden beyond the edge of the burn. For every snake removed, others continue to reproduce. And for every season of hunting, the landscape changes again. The war, then, is not a single battle. It is a long campaign. A campaign fought with fire, science, technology, patience, and an uncomfortable understanding that humans created much of the problem in the first place. The Everglades will survive the flames. It has survived fire before. The real question is whether its native wildlife can survive the predator that followed. And when the smoke clears, when the black earth begins turning green again, we may finally discover whether we are actually winning the war, or simply teaching the enemy how to hide better.